So we're going to start vectors today, and then it will run through, gotta go up to February now. We will have a test on the 5th and 6th of February on section 6.1. Okay? Right now that's tentative, okay? Because we still have some things to fill in over there yet. So that's tentative right now, it being a 2-day test. Okay? So, vectors are used to represent quantities that have both magnitude, okay, and a magnitude would be like a length or force, if you will, newtons, foot-pounds, etc. And it's got a direction. So that force, that length is going in a certain direction. And we can figure all that out after today. Okay? Now, that's my way of telling you how it is, but there's a better way to tell you all about what a vector is. Let me check to make sure that, nope, I want that on. So here is the better way of telling
you. New YouTube Red family plans. No ads for the 6 family.
YouTube's going to tell me.
Hey. I'm applying for a new villain loan. Go by the name of Vector. It's a mathematical term, a quantity represented by an arrow with both direction and magnitude. Vector! That's me, because I'm committing crimes with both direction and magnitude. Oh yeah!
So, when in doubt, learn all of your math from Despicable Me. Okay? Alright, so that's our vector. Okay? So, a vector is a directed line segment with its tail at the origin and its head at the point A, comma, B. So, I was going red, yes that was, red, so there would be the point A, comma, B. A vector would have its tail at the origin, okay, and its head, the arrow, think arrowhead, okay, you need to have that arrowhead on your vector, okay. Otherwise, it's just a line segment. Okay. And this, we write it as the vector A, comma, B. Now, when we're writing that, the last class I said, well, it's not a parenthesis, it's not a bracket. What do you want to call it? And they decided duckbills. Okay? All right? So, we'll call it duckbills from now on. Okay? So you got to make those duckbills because if it's duckbills, we're talking about vectors. If it's parentheses, we're talking about points. They mean different things. Okay? Vectors have direction and magnitude. A point is a specific spot in space. Okay? That's it. Vectors have so much more. Okay? Okay? This is called the component form of the vector. It will be the most common form of that vector. Okay? So the magnitude is the length of that vector, and we'll find out how to come up with length. I got it. Okay. Direction here now is the trig direction. So 0 is straight out to the right. Positive angles go counterclockwise. Negative angles, I said that wrong. Positive angles go counterclockwise. Negative angles go clockwise. Okay? Which is going to come into massive confusion as we get farther and deeper into this packet when we get to navigation. Because navigation, 0 is up top, okay? So we've got to convert bearings into trig in order to use it. Because when we're using it in vector form, we use it with the trig angle, not the bearing angle. Okay? Names. We use lowercase names for our vectors. Okay? We also might write them with a little, because it's hard to write in italics when you're writing. Okay? Unless you're, really good like Mrs. Hill. She can probably do it because she's skilled that way. Me, not so much. So I put a little arrow on the top, okay, of mine when I'm talking vectors. Okay? Head minus the tail rule is the next thing for vector calculations. Any two arrows with the same length and pointing in the same directions, actually that should be the same direction, not directions. Same direction represent the same vector. Okay? So we have this scenario here. Okay? So based off of that, okay, we should find the component form of vector OP. We can do that, okay, using the head minus the tail rule. There we go. Okay. So the component form of vector OP is going to be, I'm going to take which is the tail and which is the head. Which point? The head is P, right? And the tail is O, which is origin, right? So that's going to be head minus tail, the X parts, head minus tail, the Y parts, in our kissing duckbills. Okay? So vector OP is the vector 3, 4. Now, you're going to say, well, Linz, vector RS, isn't that the origin? Does that matter? Nope, doesn't matter. Okay? So, let's find vector RS now. Vector RS, which one is the head, which one is the tail? S is the head, R is the tail. So, head minus tail, head minus tail. if these were line segments, would they be parallel? Why? They have the same slope. Okay? So they're parallel. Are they going in the same direction then? These vectors. Yeah, because both heads are on the upper right-hand side of them, right? Okay. Now, if R and S were switched around, or if the direction of R and S would be switched around, then they wouldn't be the same vector because they would be going in opposite directions. Okay? But they're both going in the same direction. They both have the same size, right? So if I was magically able to, and I can't because I just copied it straight off the packet, if I was magically able to move vector RS on top of vector OP, they would be the same. Okay? So therefore, OP and RS are equivalent. I'm asking you to now figure out if we said RS here, we figured that one out already. That was 3, 4. You tell me if RS is equivalent to PQ. In vector PQ, which one's the head, which one's the tail? Q is the head, P is the tail. So that's going to be 5 minus 2 and 3 minus negative 1. Does it matter? Head minus tail, which one's head, which one's tail? Yeah. Yep. Otherwise you get negatives, which would be a different vector. Okay? So that gives me PQ here is 3, 4. Equivalent? Yep, equivalent. Okay. All right, hey. Let's get some magnitudes now. Magnitudes. Okay. So the magnitude of a vector is the vector's length. Okay. You have probably seen it if you've been in a science class and you've dealt with vectors. The symbol is that double wall. Okay? The double wall of the kind of like double absolute values. Okay? That's the symbol for the magnitude of a vector. Okay? So let's take our vector and let's figure out where it actually goes. Okay? So -2, 3 would be somewhere up in there, correct? Okay. Now, I went here -2, and then I went up 3. If I make a right triangle out of that, apparently it doesn't like that color because then it gives me the... Okay, if I make a right triangle out of that, then I can find that length, my red length, right? How can I find that red length? Pythagorean theorem, right? A squared plus b squared equals c squared. Okay? So using the Pythagorean theorem here, then the magnitude of W is going to be the square root of x squared plus y squared, if we think about x and y from the vector part. So that's going to be then the square root of negative 2 squared plus 3 squared, which is the square root of 4 plus 9. So the magnitude here of W is the square root of 13. Okay. Now, direction of W. Now we've got to find the direction of W. Well, it's going to be a trig angle that we measure from okay. So it's going to be that, right? But because we're going to have to, use some inverses, and remember cosine only works up top, and sine and tangent only work on the right side. So we're going to have to go back to our old friend old pal, our old compadre, our old amigo, reference angles. Okay? So, in order to find a reference angle, we are going to find theta prime, and that is going to be the inverse tangent of y divided by x, with a kicker, a caveat, if you will, a condition, for lack of a better term, and that condition is we are going to drop any and all negative signs. Okay? Because we need that to be a positive acute angle. So we're going to drop any and all negative signs on it. That's going to give us our acute reference angle. From there, then, we're going to use logic to determine which one it is, or what the actual direction angle is. Okay? All right. So, let's take it to this particular scenario. Remember that my vector W was the vector negative 2, 3. Okay? So then that's going to state then that the theta prime, or my reference angle, is going to be the inverse tangent here of 3 divided by 2. Okay. When you do that on a calculator, and please do that on a calculator now, when you do that on a calculator, the inverse tangent of 3 divided by 2 is going to give you that, but mine's in radians, so I'm going to multiply that by 180 and divide that by pi. That's going to give me 56.3099 degrees. Okay. Which quadrant is my vector in? My vector is in quadrant number 2. So for angles in quadrant number 2, the actual theta is going to be 180 degrees minus my reference angle. Okay? If I go back up here to my actual vector, my reference angle is right there. Okay? That's my reference angle in there. I don't want, or I want my actual angle. My actual angle is, I already used blue. My actual angle starts here and comes to there. Okay, that's my actual angle. So therefore, my reference angle here, or excuse me, my actual angle of W, and that's how we write the direction of W, we put a little W as a subscript, is going to be 180 minus 56.3099. So that's going to give me 123.6901 degrees. Okay. What I would like you to do now is I would like you to do example number 1, or problem number 1, I should say, on the next page. Find me the magnitude and the direction of vector u. Alright, so the magnitude of u is going to be the square root of the x part squared plus the y part squared. So that's going to be 1 plus 3, which is the square root of 4. So the magnitude here of u is 2. Agree? Okay. The direction then, okay, so theta prime is going to be the inverse tangent of my y part. I drop the negative sign, over my x part, drop the negative sign. It didn't have one, so I don't have to drop it. So inverse tangent of the square root of 3, well, that's going to be at 60 degrees. That one was on my unit circle. So that gives me a reference angle of 60 degrees. Now, which quadrant is this one located in? In quadrant 4? Okay, right? So this is in quadrant 4. So angles in quadrant 4 have a reference angle that takes me up to 360 degrees. So that's going to be 360 degrees minus my reference angle, which gives me my actual theta, or my direction of vector u, is going to be 300 degrees. Questions on that one? Okay. Let's go the other way. Let's find the component form of v, given the fact that we have the direction and we have the magnitude. Well, we'll probably start with the direction because we all kind of need that direction in our lives. Okay? So, which quadrant would a direction of 135 degrees be in? Okay? 2. Yep. Okay. And that's actually going to go up kind of like through in here. Okay. So right here is 135 degrees, which means what's left over? 45? As my reference angle then would be 45 degrees. Okay, good. So I know the fact that this is 6. Actually, I don't want to do it that way. I want to do it in a different color. I like color in my life. Yes. Yes. This is 6. Okay. So let's make ourselves a right triangle, right? So then this would be the y part of my vector, and this would be the x part of my vector. Correct? So how am I going to find that y part and that x part? What do you got? What do you got? Okay. We do that one thing. Okay. We could remember those. But what if we don't remember? We divide by the square root of 2. Okay. But what if we don't remember that? Use right triangle trig, right? So Katoa. Okay. So which one do you want to use first? Sine. Okay. What's sine going to find me? It's going to find me my y, right? Okay. So the sine of 45 degrees is going to be y over 6, or y is going to equal 6 times the sine of 45 degrees, which is 4.243. Right? Yeah. Now, knowing the fact that it's a 45, 45, 90 triangle, x is going to be 4.243 because it equal legs, an isosceles right triangle. Okay? But if it wasn't a 45 degree right triangle, we'd have to go the cosine then of 45 degrees is equal to x over 6, which means that x is equal to 6 times the cosine of 45 degrees. So then x here is also equal to 4.243. Okay? But is that my vector? Why not? The x one has to be negative because we're in quadrant 2. Okay? So because we're in quadrant 2, x part must be negative. Okay? So really, my vector v here is negative 4.243, comma, 4.243. Yes'm? Okay. Now, in general, okay, so in general, okay, if I need to find the component form of my vector, given the magnitude and the direction, okay, I could find my reference angles and I could, do all that stuff and then have to adjust my stuff. Or I could just say that vector v is equal to the magnitude of v times the cosine of v's direction, comma, the magnitude of v times the sine of v's direction. And the kicker is that you use the trig angle, not the reference angle. Okay? Use the trig angle, not the reference angle. If we would have done 6 cosine of 135 degrees on our calculator, we would have gotten directly to negative 4.243. 6 times the sine of 135 degrees would have gotten us positive 4.243. So we go directly to what our vector is. Okay? Very important. Okay? Very important. Alright? So, let's find a vector here. Or we have that vector. So let's find the magnitude and the direction. Go for it. I got the magnitude of v to be 5. Yes? Okay. I got the reference angle for V to be 53.1301 degrees. Yes? But V is in quadrant 3, correct? So since V is in quadrant 3, that means that I'm going to have to take, or to find theta, that's going to be 180 degrees plus my reference angle, because I'm in quadrant 3. Okay? And so that's going to give me the direction of V is 233.13 degrees. Concur? Okay. Speak now, forever hold your peace. Okay. Now, we had to do that so that we could talk about unit vectors. A unit vector is a vector that has a magnitude of 1. So the length of the vector is 1. Okay? In the same direction as, so we want to find a unit vector in the same direction as V in the problem above. Okay? So let's call this one now, let's call it U. So the magnitude of U is 1. The direction of U is 233.13 degrees. Okay? So U then, in component form, U is going to be the magnitude of U, which was 1, times the cosine of U's direction, comma, the magnitude times the sine of U's direction. So vector U is going to be negative 0.6, comma, negative 0.8. And if you do that on your calculator, or you find the magnitude of vector u, negative 0.6 squared is 0.36, negative 0.8 squared is 0.64, 0.64 plus 0.36 is 1, square root of 1 is 1. I go, like, up here, so, let me go back to, like this one, I just did that on because that's what my graphing calculator is set to, like, 6 significant digits, I think, or something like that, and so that's what it rounds to. So I throw it on there. You can round to whatever you want. I would prefer hundredths at least, you know, because tenths to me is kind of, you know, not very accurate. So, okay. So there's the unit vector for that. Okay. Now, we have special unit vectors. There are 2 special unit vectors out there. The first one is I. It is the vector 1, 0. Okay. It's a unit vector. Magnitude is 1. And J which is 0, 1. Again, a unit vector. It's got a magnitude of 1. Okay. That allow us to express any vector in the form known in math circles as a vector written as a linear combination of I and J. We can take any vector and write it using those special unit vectors. So for instance, we just did vector -3, -4, vector v. Okay? We can write vector v in linear combination form. We could say that v here is equal to -3, -4. Well, that in special linear combination form would be -3i minus 4j. Because if you think about it, -3 times I, so that would be a vector 3 times the length of I, which would be the vector -3, 0, minus, or added to, really, -4 times the vector 0, 1. So that's going to be -4 times that one. So that's going to be 0, -4. If I add those 2 vectors together, I add the x components, -3. I add the y components, -4. And it gives me that vector. Okay? I think that is a great stopping point for today. So we will pick up there tomorrow.